So compounds which consist of non-metals and metal will bond together by ionic bonds. Essentially, as you can see here, you've got a spare one here, doesn't want it, so it gives it over there, and that's an ionic bond. These form between cations, which are positively charged ions, and anions, which are negatively charged ions. Ionic bonds form electronegativity differences are very different, and you get this table salt example of NaCl. Now, compounds which consist of non-metals chemically bonded together usually do covalent bonds, and usually its molecules are the exact same. They have no difference in electronegativity. So therefore, they're going to share like this. So example, you've got all these here, which are their own, but then they share these two. So this was one from this chlorine, this one was from this chlorine, and now they share them. So covalent bonds form, and electronegativity difference between the non-metals are relatively low. So that's what's going on there. So as you can see, you've got covalent bonds, electrons shared, and then you've got ionic bonds, so electrons transferred. So, bonding. Explore the similarities and differences between the nature of inter and intramolecular bonds. Now, this is more of the important side of things. This is more where I would split my bonding, where I would say, all right, this bonding is intermolecular, this bonding is intramolecular. I like to split my bonding here better than where I did it earlier. So intermolecular versus intramolecular bonds. It's really important you don't get these two words muddled up. You need to make sure you can separate them. Intermolecular, think of it like internet. The internet, you can go anywhere. You can do whatever you want. You can go wherever on the internet you want. Intranet is within a small space. So your school will have an intranet. Maybe you use Moodle, or maybe you use a different program where it's online, you need internet to access it, but essentially it's just shared files between your school. You can only access it through your school. It's got only school stuff on it. That's an intranet. It's an intranet because it's within a system. Internet is over the systems. So think about it in terms of molecules. Intramolecular bonds with an A, they are bonds within the molecule. So they are the covalent bonds where they share electrons. Intermolecular bonds are if I have two separate molecules, so I had a chlorine and a chlorine, and my intramolecular bonds was those covalent bonds between the individual chlorine atoms. But now I've got one of them here, and I've got one of them here. What about between those two molecules? Is there attraction at all? Well, there is, and we call these intermolecular bonds. So they're between molecules. So intra, think of covalent and ionic. Inter, we're going to talk about some different ones, such as dipole, hydrogen, and dispersion. So you need to know this for year 12. They are responsible for differences in melting and boiling point. These are forces that tend to be tested more often. So you have three different forces or three different types of intermolecular bonds. Dispersion forces, dipole, dipole, and hydrogen. Now these go in strength order. Dispersion is really weak. Dispersion is in everything. Everything has a dispersion force. When I pick up this drink bottle, there is a dispersion force between atoms in drink bottle, plastic, and my finger. Yes, it doesn't exactly explain why I'm picking this up. There are other things that explain that, but there is a dispersion force between those atoms. It's literally a thing that happens everywhere. Dipole, dipole are when you have polar molecules. So polar molecules are dipole and hydrogen. Non-polar is dispersion. Polar is also dispersion. There's dispersion between everything. Now, dipole, dipole, you need to be a polar molecule, so you need to have some slightly stronger, some slightly difference in electronegativity, so you need to have a slightly positive and a slightly negative area. And essentially, dipole, dipole is just between any polar molecules. Now, hydrogen are special types of dipole, dipole. So they're a type of dipole, dipole, but they're special. These are between what we call the NOF rule, N-O-F. Hydrogen bonded to intermolecularly, so it's not like a full bond, it's just like an intermolecular bond between a nitrogen, an oxygen, and a fluorine. So if a molecule has a hydrogen and it forms a dipole-dipole bond with another polar molecule that has a nitrogen, an oxygen, or a fluorine, it will form a hydrogen bond. This is slightly stronger than a dipole-dipole and can explain why melting points or boiling points increase a bit more in some molecules that have nitrogen, oxygen, fluorine, or a hydrogen, although they need at least two of them. That's why we call it the NOF rule. Some people call it the FON rule. I call it the NOF rule, the nitrogen, oxygen, fluorine.